Welcome back to Outward Home Learning. The subject that we're doing today is computer science, and the topic that we're looking at is merge sorts. So it's one of the sorting algorithms that you need to know about for GCSE. First off, we're going to go over to Mr. Holton, who'll explain it, and then you've got some activities to complete. Over to Mr. Holton.
Merge sorts then. So these are actually kind of efficient merge sorts. They're used in computers, whereas the other ones, bubble sorts, insertion sorts, probably not. But you might have a good chance of finding a computer using a merge sort to do something useful. So let me walk you through it then. It's called a divide and conquer algorithm, and there's a good reason for that, in that it takes a big list like the one I'm writing out now, and the first thing it does is divide it up and keep dividing it up until it gets to lists which have got all the length of 1, and that will sort of make sense as I'm going along. So to start with, I've got this big list of numbers here, and as you see, it's got 8 numbers in, so the length of that is 8. So first thing I'm going to do is divide that into 2 here. Okay, divide it into 2 with that blue wavy line. I'm going to write out the numbers again. You'll see why in a little bit, but now I've got 2 lists which have got the length of 4 because they've got 4 numbers in them. And what I do is the same thing. I divide them again. So now I've got, well, I will end up with 4 lists with 2 items in them each. And then the same again, but this time when I divide them up, because I've got 4 lists with 2 items, I'm going to end up with 8 lists with each one only having a single number in. And that means I've reached the end of my divide part of the divide and conquer algorithm. Okay, on to conquering then. So I've divided up my list successfully, and now I need to recombine them along the same lines that I divided them before. So what I mean by that is the first set of numbers I'm going to consider here are 43 and 26, our first list with 2 numbers in it. And so which one's lower? I've got 43 here and I've got 26 here. Which one's lower? Well, of course it's 26, so that goes first in the list, and then 43, so that comes next. And then I'm going to go over to my next sub-list here, so my next list of 2, 18 and 34. Which one's lower there? 18, then 34. And then on to my next list here. Which one's lower? 53, 31, and 53. And you notice I'm doing this along the same lines that I divided the lists into before. So 42 and 99 now go like this because they were 99 and 42 earlier on. Okay, so far so good and so simple. I follow the same process for the next set of numbers. So I recombine my lists of 2, and now I need to recombine my lists of 4. But because I know my lists of 2 are in order, I only need to look at the first number for each of them. So and that's the beauty of the merge sort, you'll see in a moment. So I've got 26 and 18. Which one's smaller out of those 2? Well, 18, of course, so 18 goes down there. And then I move my squiggly line along here to 34. And so which ones am I considering? Just 26 and 34. Which one's smaller there? 26, of course. The line moves up, 43, 34. So I've got 34 next. I can get rid of that line now because I've used all the numbers in my sublist here, so I know I've got 43 left over. And I do exactly the same thing on the right hand side. So again, along the same line that I divided them before. So I've got 53, 31, 99 and 42 that I'm going to be ordering. 31 and 42, which one's lower? 31, then 42, then 53, and then 99. Okay, I've recombined my lists of 2 now into 2 lists of 4, which means I've got to do one more final recombination here, okay? And I do exactly the same process as before. I'm only looking at the first number of each of the lists, so 18 and 31. So which one's lower? 18, that goes there. Which one's next? And obviously I'm moving my squiggly line up 1 now to 26, so I've done 18. So which one's lower now? 26. Then I've got 34, 31. Which one's lower? 31. Then 34. Then I can move that up. So I've got 42 next. They can move that up. 43. And then I'm just left over with 53 and 99. And if I look down the bottom, my list is now sorted. Okay, we're all done. And that's the beauty of merge sorts. They can quickly recombine the lists after you divide them up into lists of 1 to put the whole thing in order. And that's why they're so efficient. Just a final reminder, this obviously works again on letters as well as numbers.
So now that you've heard a bit about how merge sorts are performed, you've got some tasks to complete where you're going to complete some partially completed merge sorts. You've got about 10 minutes to complete these, so please don't rush. Please do it really carefully, and then Mr. Barnes will review your answers afterwards. Off you go. So now you've had a chance to complete those activities, we're going to go over to Mr. Barnes, who will review your answers.
Okay, so let's have a little look at this merge sort activity that you're given. First of all, you're given an example of how the process works. So you should have hopefully looked at that, followed that through, and then used the video that you will have already watched as well to be able to complete these tasks. So let's have a look at task 1. Task 1 is perform the merge sort. So we've got 6 numbers. So the middle is there, perfect. And what we're going to do is going to split into 2 sublists. So the first stage is 2 sublists. So I'm just going to write 24, 16, 5, 9, 12, and 6. There is no sorting yet. We need to split them into their individual elements before we start sorting. So then we split into a 2 and a 1. So we've got 24 and 16 in this one. And then we've got 5 in this one. And then we've got 9 and 12 and 6. And then we repeat the process to get them into individual elements. So we've got 24 on its own, 16 on its own, 5 on its own, then 9, 12, and 6. And at this point, we've not actually sorted anything, but we've done the first stage of a merge sort, which is to split everything into its sublists, or into its subarrays, one element each. So the next stage is then merging them back together. So we need to merge the 2 individual elements into a pair, and at this point, we sort them. So we put 16 and 24, they need putting round, and 5 stays on its own for this step of the process. We then do the same again, so 9 and 12 are actually in order, so we're just going to leave them as they are, 9 and 12, and 6 on its own. We then need to merge the 2 and the 1 subarrays into a bigger one, so we need 5, 16, and 24, and then we do the same with the other one where 6 goes at the beginning, then 9, and then 12, and then finally we merge those 2 sublists together, so we will end up with 5, 6, 9, 12, 16, and 24. Okay, So let's now repeat the process, but this time we use letters, so we're looking at alphabetical, and then we'll talk about why are we doing this process, because it does seem a bit pointless to humans, but we'll go through that. So this time we've got 5 elements. So where do we split it? We can't split it down the middle of C. I've given a little bit of a giveaway here. We're going to do it in a 3 and a 2. However, you could also do it in a 2 and a 3, but obviously we've given that structure, so I would do it as a 3 and a 2. So we're going to go Y, D, C, R, J, and then we're going to split Y, D, and then C, and then R and J into single elements, and then because the left hand side is not already split up into individual elements, we need to just repeat that process again. So Y, D, C, and then R and J. So we split them into their individual elements. It's now time to start merging them back together. So we've got Y and D, well they're the wrong way round, so that becomes D and Y, and then C on its own, and then R and J, they're the wrong way round, so we've got J and R. We then have to merge the 2 and the 1 here together again, so we're going to go C, D, Y, and then J and R stays as it is. And then finally we remerge again, so we've got C, D, J, R, Y. Okay, so that does seem a little bit pointless to humans, that we have to separate them into individual elements, then put them back together. The key thing here though, this is used by computers, and computers need a set of rules to follow. They can't use common sense to go, well that's in order, that's not in order, and that's really, really important. And the merge sort, although it seems pointless, more so than maybe the bubble and the insertion for us, this actually has a consistent runtime. So with a bubble sort, it exponentially increases how many times you need to go through and check. Whereas this is quite consistent because it's almost like a divide and conquer approach. You're splitting the list in half, half, half again. So you get a much better runtime. So the final part of this activity was to perform a merge sort on these numbers, but it was without the structure we've given you before. So the key thing here is we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. So how would I do this in an actual example? You could obviously draw it like we've just had on those structured examples, but this is how I would do it. I would simply put 101, 56, 23, and 90, and I would put a box around them to signify that they're now one list. And then I would do the same with the other 4 to show I've split it in half. And then I'd repeat the process. I've got 101 and 56, I put a box around them, 23 and 90, I put a box around them. And I do the same with the other side. So I'll show you this in a minute because I realise my hand is probably in the way. It's not great when you're left-handed. Okay, and then I'd split them into individual elements. So I'd have 101 in a box, 56 in a box, 23, and then 90, 124, 68, 43, and 12. Okay, so now I split them down. That's the first step. I then need to merge them back together. So I'm going to have 56 and 101 in a box together. I have 23 and 90 as they were because they were already in order. Then I'm going to have 68 and 124, and then 12 and 43. Repeat the process again, so it is quite long-winded. So I'm going to go 23, 56, 90, and 101 in one, and then I'm going to have 12, 43, 68, and 124 in another. Excuse my really poor handwriting. And then one final merge, so I'm going to have 101. So I'm going to have 12, 23, 43, 56, 68, 90, 90, 101, and 124. By putting those box rounds, it makes it really, really clear. So the final thing that you needed to do was list the steps involved in the merge sort. So, what are the steps that you go through? So I would say the first one is to split the list into sublists until they are individual elements. So that process is where we've gone into fours, pairs, individual. That's this bit here. Let me change the colour of the pen. So that step 1 is this bit here. Okay. Then the next step is going to be take individual elements, sort, and merge into pairs. Okay, and again I'll signify that. That is this bit here. Okay, so step 1, step 2. And then this could obviously, depend on the size of the list, go on and on and on. So I'm going to say repeat step 2, merge in 2 sublists together and sort in until one list. Okay, and that is this bit here. And that's this bit here, sorry. And that is overall how a merge sort works. You will not be asked to write the algorithm for it, simply perform it and be able to explain how it works.
Okay, so time for some exam questions so that you can prove you have learned how to do these merge sorts. I'm going to give you 10 minutes, and as ever, they'll be reviewed by Mr. Barnes afterwards. Give it your best shot. Off you go. And that is time up. Hopefully you managed to get some good answers to those. So we're going to go over to Mr. Barnes who'll review them. Please make sure that you correct your answers if they were wrong in any way.
Okay, so now we've learnt about merge sorts, it's time to put in this into practice with some deliberate practice on exam-style questions. So we've got here, Fern is developing an application to track car number plates as they drive past to be verified against a national system to check for valid car insurance. I've got a list here of 8 different number plates that have been captured. Okay, so we've got to follow through the process or the stages of the merge sort. So the first thing I'm going to do, and it's easy to think about cutting corners here and just writing down the first couple letters, but let's not do that. So I'm going to split it into 2 lists of 4. So I've got, okay, with a little bit of camera wizardry, let's speed this up. Now we need to split them again. And now we're in pairs, and now we have to do it all again. So okay, so now we've got them in singles. Finally, we then need to merge them back together in order. So we take the first 2 individual elements and put them into a sorted pair. So I've got. So now they're in pairs. We now need to merge them into 4s. Now we've got them in 4s, we merge them back into one final order. Okay, finally, we're there. So, the next thing to do is just have a little look at the mark scheme. So this will be worth 4 marks in an exam. So it says the list is split into individual elements. This may be done over several steps or as a starting point. So I've done it as several steps, split into 4, 2, and then singles. But you could have just done it like that, but I think it's better to be complete. So we've got 1 mark there. Merge individual elements into sorted lists of 2. Perfect. Merge lists of size 2 into lists of 4, and then merge lists of 4 into sorted list. 4 marks.
And now you've learned how to do merge sorts. Stay tuned for the next lesson. Another one will be added to the website very soon.